Okay, so lesson 7.4, we are still working with similarity. Okay, what are the two ways that we've done to tell them they're similar? Sides and angles. Okay, how did we prove sides?
Yes.
How did we prove sides? Their ratios, right? Seeing if their ratios were the same. How did we prove angles? How many did we need?
You needed two angles that were the same.
We needed at least two. Okay, so today we are doing similar type stuff. On these two shapes right here, what do we need to do to prove that they are similar to each other?
You use the sides.
You use the ratios, right? So if I start with 8,
You have to do 4.
8 goes with 4, so I need to start with 8 over 4.
Divide by 4, that gives you 2.
Yep. We end up getting 2. Now we have to check all of them. Why do we have to check all 3 and not just 2? They all have to be the same, okay?
12 over 6.
Yep, 12 over 6 goes together.
Divide by 6.
We divide, we get 2. And then what's my last ratio? Yep, 10 over 5.
Divide by 5.
We get 2. What does that tell us?
It's similar.
They're all the same, so they are similar, and we've been putting yes.
What?
Okay? So that process there is the same as what we've always done. You just have to do all 3. Okay? All 3 on the triangles. Any questions on that? We've done a lot of practice with those.
No.
Okay? Do I need to do another example together? Or are we okay?
We good.
Okay. Go ahead and try number 1. Only have to do number 1. You don't have to do 2. Do number 1 using the ratios of the sides. Okay? Do number 1. Okay. What is one ratio that I can put together on number 1?
12 over 8.
No.
Yep. 12 and 8 go together. What can I divide both 12 and 8 by to reduce? Yep. Divide by 4, we get 3 over 2. Okay, somebody new, give me another ratio that we can use. What? 18 over 12, good. What can I divide both of those by? 6 to get 3 over 2. Can I assume the last one?
Yes. No.
No, don't assume. What is the last ratio I can have? Since we started with A, that triangle, we had to flip it, but good job. 15 over 10. What do we divide both those by? 5 to get 3 over 2. What does that tell us?
Actually, it's 1.5.
That tells us yes. And when we put yes, what are we really meaning by yes?
Similar.
Yes.
That they are similar to each other. Good. One last thing to look at today. Way back when, what did SAS mean? Side, angle, side. Okay. What was important with that acronym?
I don't know.
It was the order.
The order mattered, right?
Side, an angle, and a side.
Yep. In the picture, it has to be in that order. Connected. Side, angle, side. We cannot jump across the triangle to make it true. Okay. Has to be all connected. So on this one, we have to prove all 3 of those possibilities. Okay. So what I advise, look for the pattern first. On number 3, do we have that pattern? Do we have side, angle, side? Yes. Now we have to check that they're both true. Check the angle. Do we have an angle that matches?
Yes, 90.
That 90, right? 90 matches, so the angle is good. Now we have to check the sides. How do we check the sides? By their ratios, right? So 8 goes with 6. 8 over 6. Divide by what? 2 to get.
4 over 3.
You got it. And then what's my other ratio I have to try?
12 over 8.
Yep. 12 over 8. Divide by 4. What do we get? 3 over 2. What does that tell us right there?
They're not similar.
Not similar. They're not the same. So what's my overall answer?
No.
No, they are not similar. What's your question?
Does it matter what order we going? Like 8 over 2, 6 over 8?
Well, let's put them in one.
As long as
It doesn't matter.
Doesn't
Doesn't matter as long as you keep them the same.
Okay.
Yeah, so if you start with 8.
So if you start with one triangle, you have to keep starting with that triangle.
That's mine.
Okay? Looking at number 4,
Oh, this one's easy.
why does this one look a little funky?
It's because they're the same numbers.
Because there's 2, they're overlapping each other. They're overlapping each other, okay?
You're gonna share the.
I'm going to redraw the bigger triangle, okay? What are the side lengths of the bigger triangle?
6.
No, you're right.
10.
Yep, because we have to combine these two sides, add them together. So we get 6 on one side, and then we get 10 on the other. And then we still have that little triangle that overlapped,
3 and 5.
and its side lengths stay the same. Yep, 3 and 5.
They've got one similar.
So we are still doing side, angle, side. Check an angle. Do we have an angle that matches?
Yeah.
Right, that overlapping angle we talked about yesterday. P is the same angle measure. Okay? Once we have the angle, what do we check now?
Sides.
Check the sides. If I start with 6, it goes with
3.
3. What do we get when we divide those?
Divide by
2 over
3,
1.
2 over 1.
Actually, 2.
So 2.
Yep, we end up getting 2 if I
10
divide
over
by
5,
3.
Divide by 5.
So now we have 10 and 5,
2 over 1.
so we end up getting 2. 2 over 1 is the same thing as
2.
just 2. Yep. So what does that tell us?
Yes. They're similar.
Yes. Awesome. Any questions over today?
No.
The only new thing we just added was that side, angle, side. The others were very similar to what we've been doing. Okay? All right.